Alright, welcome to Physics Lesson 4.3 Cliffhangers. Alright, the first thing we need to talk about is something called horizontal velocity. Now, we talked about this previously in other physics lessons, especially when we were dealing with linear motion in one dimension. But horizontal velocity, that's going to involve how fast an object is moving, either forward or backwards. So if you think of your coordinate plane like this, I'm sorry, that's not straight, this would be your x. So an object would be moving along the x-axis. Right? Now, the velocity of that would be how far it's going over how much time. And we label that vx. Alright. If there's a horizontal velocity, we also have a vertical velocity, which, similar to the horizontal, it's how fast something is moving and in which direction. Only now, it's how much is it moving down or up, right? And we signal that by Vy, and it's still measured in meters per second. One of the hardest things about this section is being able to identify vertical and horizontal motion. I'm going to jump right into our practice so that we can figure some of this stuff out. So we have a cannonball. And the cannonball is going to be shot off of a cliff which is 20 meters tall. If the cannonball has an initial velocity of 30 meters per second, how far from the base of the cliff does the cannonball land? Alright, so there's a couple of steps that we have to work on. First, I'm going to go ahead and draw our picture. So there's our cliff. The cliff is 20 meters tall. So delta y equals negative 20 meters, because remember, it's going to fall. Here is our cannonball. Here's my really bad cannon. Some whoosh marks because it's shooting outwards. It's shooting outwards with a horizontal velocity of 30 meters per second. So this is just affecting the horizontal. It's not saying anything about vertical. 30 meters per second because it's shooting straight outwards. Alright, then we're going to break into a couple of rules. But before we start in this problem, let's look at some rules. So big rule number one, horizontal velocity will always remain constant. And that is going to be one of your best friends because that means that velocity equals delta x over time. Because whenever it remains constant, we can use our average velocity formula. And on your equation sheet, actually change that so that it says constant, so that hopefully will help remind you. And I also have it set as horizontal. You're welcome. The second big rule is that a projectile will fall down at negative 10 meters per second squared. And it has no effect on the horizontal motion. So the horizontal motion is still going, that way or that way. Gravity only pulls things down because gravity sucks. Alright, so back to our problem. The first thing we need to do is figure out when this object is going to land. So that means we need to solve for time. But since I don't know how long it's going in this direction, the only thing I can focus on is the vertical part. So its vertical velocity is actually 0 meters per second. Because I'm not shooting it up, I'm not shooting it down, it's in a way just dropping from 0 all the way down to negative 20. So let's figure that out. Delta y is negative 20 meters. That should equal half our acceleration, which is negative 10, times squared, plus 0 times time. So now we know right away, because velocity is 0, that we don't need that part. And we're left with negative 20 divided by negative 5 equals t squared. We're going to get rid of that t squared there. And we should end up with a time of 2 seconds. Sweet. So now we know when it's going to hit, but we still don't know where it's going to hit. But thankfully, big rule number 1, velocity is constant. Because I know the time that it fell, I also know the time that it traveled over. The time is the same for each. So it's falling and moving over with the same amount of time. So going back over here, if our velocity is 30, our time is 2, then our delta x, or where, that was weird, it's going to land, should be just 30 times 2, which is 60 meters. So this is going to do one of these numbers, and land 60 meters from the base of the cliff. Yay! Alright, stay tuned and we'll figure out, well, I'll go through anyway, how I came up with this path and how graphing this motion makes sense into our drawing. Okay, I will see you later.